Study Section 2, The Goods Market. Introduction. Economists all over the world always ask the question as to what accounts for the year-to-year movement in economic activities. To enable them find answer to this question, they study the interactions among the aggregate spending, aggregate output, and national income. The thinking is that there tends to be a strong link among these three variables. As shown in Figure 2.1, a change in total spending tends to lead to a change in output and hence a change in national income. Recall that these are the three approaches used to compute national income. For example, if aggregate consumption or investment increases, aggregate spending will increase and firms will respond by increasing output. Increase in output will generate employment and hence increase in income. Increase in income will lead to further increase in demand and the movement along the triangle continues. A critical study of this interaction is very important, particularly for policymakers. Also, the implications of these interactions are of topmost importance. Hence, this chapter is devoted for analyzing the interactions among income, spending and output, and also to point out some implications therein. Objectives of study section. At the end of this chapter, you will be able to do the following. Identify the components of aggregate spending. Analytically explain the adjustment mechanism following a distortion. Understand the idea of causality correlation trap. Components of GDP. We begin by analyzing the agent that produce national output and the agent that buy them. In any standard microeconomic textbook, the components of GDP are collapsed into household consumption, represented by C. Firms, purchases of capital, intermediate goods, and level of inventories, E. Government final consumption spending, G. and net export, NX. Consumption, which is the first component of GDP, consists of goods and services bought by the consumers for the purpose of final consumption. These goods range from basic needs, food, clothing, shelter to luxury goods like state-of-the-art electronics and electrical appliances like washing machine, electric cooker, house elevator, sophisticated cars, the so-called machine, etc. The residential investment is the newly completed and purchased houses or new purchased apartments. Non-residential investment are the capital and intermediate goods like generators, machines, computers, furniture, mobile phone for commercial purpose, etc. The decision behind the two investments tend to be the same. For instance, the reason why more mobile phones or computers are needed is to supply more services to people. Building and purchasing of houses or apartments is also for the purpose of providing more housing services. Because of the similar feature, the two are lumped up to make aggregate investment. It must be recalled that the way economists conceptualize investment is different from how non-economists conceptualize it. For example, anybody holding share certificate or any asset might consider that as investment. Yes, this is true, but such investment is called financial investment and not fixed investment. Table 2.1 shows that in 2004, aggregate investment was 456.9 billion naira and constituted just 4% of GDP. This implies that fixed investment accounted for very small percentage of GDP in that year. This contribution of investment to GDP has an important implication on the economy, as we shall see later. Government expenditure, which is the third component, comprises goods and services purchased by the federal, state, and local government. We know that government purchases some goods like ships, vehicles, aircraft, building, equipment, stationery, etc. Government also renders some services through its employees, such as the money spent on elections, payment of INEC permanent and ad hoc staff, money paid for the development of constitution, money paid to judges, lawyers, defense members of houses of assembly and senate, federal and state government parastatals, etc. The services provided by government employees, such as health, education, defense, etc., are treated as the purchase of services by the government, and so it is sometimes called expenditure on the provision of public services. It is important to distinguish between government expenditure and government transfer. Government expenditure is an expenditure carried out with the hope of getting returns. Government transfer, such as social security, pensions, interest paid on government debt, are expenditure that government does not expect returns. Export are the purchase of Nigerian goods by foreigners, and import are the purchase of foreign goods by Nigerian consumers. Exports are added while imports are deducted. The difference between the two, export and import, is called net export or the trade balance. If the difference is positive, an indication that export is more than import, Nigeria will have trade surplus. If the difference is negative, an indication that import exceeds exports, Nigeria will experience trade deficit. In 2004, the table reveals that exports constituted 40% of GDP, while imports constituted 17.4%. Thus, the net export was 23%. This implies that the country experienced trade surplus in the year. Trade deficit or trade surplus provides important information about the economy. This information will be closely examined in the subsequent chapters. If we add up line 4 to the first 3 lines, we get total purchases of Nigerian goods and services. However, this does not give us the true picture of Nigerian production in the year. This is true for at least 2 reasons. First, not all goods produced in the year will be completely sold in that year. Second, some goods that were consumed in the year were actually produced some years back. Thus, to get the actual value of goods produced in 2004, for example, we need to account for these scenarios. The difference between what we produce and sell is called inventory investment. If we purchase some goods that were produced in the earlier years, it means we sell more than we produced that year, and so we need to make up for the excess by reducing our inventory. That is, any year that purchase sale exceeds production, inventories will fall. If, on the other hand, we could not purchase all what we produced within a year, we have to carry the leftover to the following year. This scenario will increase inventories. Thus, note that when purchase exceeds output, inventories will fall. When output exceeds purchases, inventories will rise. Model of output determination. We define output as the total amount of goods and services produced by a country within a year. In the earlier section, we decomposed GDP into 4 basic components. This invariably describes the demand for goods by the spending agents. If total output is represented by Q, it is possible to write the following identity. That is, total output, which is identical to total demand, is the sum of consumption, investment, government spending, and net exports. Equation 2.1 is called an identity. If we assume that a country does not trade with the rest of the world, that is, the country tends to be self-sufficient, then the term in the bracket will be eliminated. We shall assume that this is the case for a moment in order to make the analysis simple and tractable. We shall later relax the assumption in due course. The question we want to answer is, if countries of the world were to operate within individual boundary, how would the economy behave? Later, when we relax the assumption, it will be easy to compare the behavior and draw important implications for policy response. The second assumption is that all firms produce identical goods. That is, consumers have no choice to discriminate among varieties, and firms cannot discriminate among capital goods. In other words, the goods are strictly homogeneous. This gives us opportunity to concentrate on only the market for goods. and this is the reason why the model is about the good market. Following this assumption, it is expected that all players in the market will take price as given. The implication of this is that if cost rises due to increase in output, price may not necessarily rise. Hence, demand behavior will tend to affect price, and so we then focus on the role of demand in output. That is, we assume that demand creates its supply. In particular, this model will examine output movement in the short run. Our focus, therefore, is to study factors that determine output in the short run. With the assumption of closed economy, demand for good, Q, is the sum of consumption, investment, and government spending. That is, we now discuss the economic behavior of each component. Consumption C. Theory and practical experience show that income, specifically disposable income, is the major determinant of consumption. Disposable income is the income that is available for spending after the recipients have paid taxes T and received transfers B. That is, when disposable income widely increases, maybe as a result of increase in income, increase in transfer, or decrease in taxes, there will be more money available for spending, and as a result, consumption will increase. Equation 2.4 summarizes this assertion. The term C prime greater than 0 implies that there is a positive relationship between consumption and disposable income. The term on the right-hand side is called consumption function, and as it is, it shows the relationship between consumption and its determinants. While there are other variables like age, education, and so on that may likely determine consumption, we shall stick to income as the main determinant. The equation itself is called behavioral equation of consumption. It shows how consumption behaves to changes in income and some other variables that determine it. The behavioral equation shown above is not analytical. To explicitly show this relationship, we shall assume that the consumption function is linear as specified in equation 2.5. The first parameter, A, is called the intercept. It tells us the amount of basic consumption that is carried out when the consumer was not earning income. The second parameter, B, gives the effect of consumption when income changes. We can also say that the parameter measures how consumption responds to changes in disposable income. If we assume that B is 0.6, it means that consumers will increase consumption by 60 kobo for every 1 naira increase in disposable income. Ordinarily, we expect the parameter B to be positive, meaning that the consumer will surely spend part of the increase in disposable income on consumption. Also, we expect the consumer not to spend all the increase. He should save part of the increase. Thus, the restriction imposed on B is that it should lie between 0 and 1, that is, 0 less than B less than 1. Given this description, it is easy to represent the relationship on a graph as shown in figure 2.1. If we incorporate equation 2.3 into equation 2.5, we have the equation says that consumption is a function of transfer and taxes. Now, if we assume for a moment that transfer adds to income, or we assume that the difference between transfer and taxes is net taxes, then we can eliminate the B in the bracket so that we rewrite the consumption as a function of income and net taxes as follows. In the consumption function, we found out that consumption depends on the changes in income and taxes. Thus, consumption treated as exogenous variable in equation 2.1 is actually an endogenous variable because it depends on other variables including income. In the case of investment, we shall assume for a moment that it is not explained by other variables and so it is treated as an exogenous variable. Treating it as exogenous is just to make the model very simple to explain. If we treat investment as exogenous, we are saying that investment, then we can eliminate the B in the bracket so that we rewrite the consumption as a function of income and net taxes as follows. In the consumption function, we found out that consumption depends on the changes in income and taxes. Thus, consumption treated as exogenous variable in equation 2.1 is actually an endogenous variable because it depends on other variables including income. In the case of investment, we shall assume for a moment that it is not explained by other variables and so it is treated as an exogenous variable. Treating it as exogenous is just to make the model very simple to explain. If we treat investment As exogenous, we are saying that investment does not respond to changes in output/income. Of course, this appears to be a departure from reality because firms tend to raise investment following increase in output. This is true and we recognize it, but it is also possible for firms to change investment irrespective of changes in income. Thus, it makes sense to first start with how changes in exogenous investment will affect output before delving into how investment is affected by output. Because investment is exogenous, we will specify it as follows. The subscript implies that investment is exogenous. Government expenditure G. Government expenditure and taxes are government fiscal policy which describes the choice of spending and taxes that government want to choose. Government spending and taxes will be treated as exogenous. Treating G and T as exogenous again appears trivial, as it dissociates from real-life situation, particularly in Nigeria, where government also participates in production of goods and services. However, one important rationale for treating government spending as exogenous is that government spending is predetermined as it is spelled out in the annual budget. Recall that the task of macroeconomists is to advise government on spending and tax decisions, and so it is not important to examine a model in which we have already assumed something about their behavior. Another important reason is that taxes that depend on income in Nigeria tend to be very small, and so its effect on output is likely to be meager. We shall strictly assume that taxes and government spending are purely exogenous, and so government spending function will be as follows. The equilibrium of the model. Putting all the pieces together, it is possible for us to determine the equilibrium point. At equilibrium, total output will be equal to total demand. That is, now we need to substitute equation 2.6, 2.8, and 2.9 into the above to get equation 2.10. If we assume that inventories are zero, then equilibrium in the goods market is the condition that the supply of goods Y be equal to the demand for goods Q. That is, this is called the equilibrium equation. Any economic model is usually composed of three types of equations: the behavioral equation, the identities, and the equilibrium. Our model captures all these equations. If we substitute equation 2.10 for Z in equation 2.11, we have the next step is to summarize our discussions so far. The summary is presented in equation 2.12. This equation captures the mechanism through which production equals demand. Demand in turn depends on income and taxes. This is not surprising because income and production are assumed to be identically equal. As said earlier, output and expenditure are two ways of looking at GDP, one from supply side and the other from demand side. Equilibrium solution, algebra and graph. We proceed by solving the model so as to see clearly variables that determine equilibrium output. We shall use the tool of algebra and graph to do this. Again, we will examine the response of output, income to changes in income, taxes, government spending, and investment. That is, we shall characterize the result with the aid of algebra, graph, and in words. You will recall that these are the toolkits used by economists in their research. Algebra to make sure that the logic is right, graph to build the intuitions, and words to explain the results. Algebraically, the equilibrium output is determined as follows. To get a clearer picture of this argument, let us start from balanced budget condition. This implies T is equal to G. If marginal propensity to consume B is less than 1, then G minus BT will be positive, and so autonomous spending will be positive. Since taxes are the only source of revenue, it turns out that government will have to increase taxes substantially. We shall ignore this possibility but bear it in mind that it is also possible for autonomous spending to be negative. The first term, 1 over 1 minus b, is the multiplier, and since b is greater than 0 but less than 1, the solution values take 2. The solution value is necessarily greater than 1. This term is called the multiplier and tells us the numbers of times income will change for a unit change in any of the autonomous variables. The larger the value of b, the larger the multiplier and the more it affects output. For example, assuming that b is 0.6, the multiplier will be 2.5, which implies that if investment or government spending rises by 1 billion naira, output will increase by 2.5 billion naira. Hence, increase in any of the autonomous variables will lead to increase in output more than the direct initial effect on the autonomous spending. Where does the multiplier come from? It comes from equation 2.12. An increase in investment, say, will increase demand. The increase in demand then leads to an increase in production and income. The increase in income leads to increase in production and income. Increase in income leads to increase in demand further, and so on. The graphical illustration represented in figure 2.3 brings out the picture clearer. The graph plots the output and demand function of income. The equilibrium is the point of intersection of production and demand. The 45-degree line implies income and demand are proportional, demand and production are always equal. When income is zero, output equals autonomous spending. The slope of the line is the MPC B and it satisfies the restriction imposed on it. The line is upward sloping but with slope less than 1. To the left of E, demand exceeds production, and to the right, production exceeds demand. Only at E are the two equal. This means that the equilibrium is unique, stable, and linear. Now, suppose that investment increases by say 1 million naira at a given level of income, what will happen to GDP? First, due to sudden rise in demand, there will be a parallel shift of the demand line as shown in figure 2.4. The new equilibrium is at E prime. At this point, equilibrium output increases from Y0 to Y1. We see that the increase in output generated measured by the difference in output is greater than the initial increase. This increase is informed by the multiplier effect. How does the economy move from E to E prime? Increase in investment leads to increase in aggregate spending to point Z. Point Z shows that demand is 1 million naira higher and so firms have to respond by producing as much as 1 million naira more of output. The increase in output moved the economy from point E to point N. At point N, income has increased by 1 million naira and part of it will be spent, thereby increasing demand, but less than 1 million naira. The demand is at point D. The increase in demand further generated increase in supply. This process continues until the economy is at point E prime, where output and spending are equal. To consolidate the analysis, the first thing the analysis shows is that increase in output depends on increase in demand. If demand rises, output will rise. Demand, on the other hand, also depends on income. The higher the income, the more the demand. Income will be higher if people are unemployed or the present employed workers work for more hours to produce more output. The initial increase in spending is smaller than the eventual output created by the value of the multiplier. The higher this value, the greater the magnitude of effect. The magnitude of the multiplier in turn depends on the value of the marginal propensity to consume. The higher the value, the greater the magnitude of the multiplier. Although this analysis was based on the effect of increase in demand, we can also make an example of a decrease in demand, in which case the explanation takes the reverse order. For instance, if there is a drop in consumer confidence, output might fall and this tends to generate low income and hence low output. Leakages and injections approach. Another way of looking at equilibrium of demand and output is to focus on the magnitude of investment and saving. John M. Keynes was the first economist to use this approach in his model. He defined saving as the difference between disposable income y raised to power d and private consumption, that is. But we know that y raised to power d is y minus t, and so also at equilibrium it is required that, substituting this into 2.15, we have equation 2.16 is called the IS relation. The term in the bracket is the public saving if government is running budget surplus, but it will be public saving if the government is running budget deficit. The equation says that equilibrium in the goods market is such that private investment must be equal to the sum of private saving and public saving. If the government deceives, private investment will be affected negatively to maintain equilibrium. The 1 minus B is called marginal propensity to save. It tells us how much people save out of an additional unit of income. The restriction imposed on B is also imposed on 1 minus B. That is, it is greater than 0 but less than 1. We see that saving depends on level of income, taxes, and MPC. How do we solve for equilibrium income? Substitute 2.17 into 2.16 and simplify as follows, which is exactly what we got in equation 2.13. Paradox of saving. The equation describing the IS relation shows that increase in saving will lead to increase in investment. But is this always the case? If consumers increase saving at any level of income, saving will increase, no doubt. But income becomes lower. Note that we assume that investment does not change, and so at equilibrium, saving will not also change. While people want to save more at a given level of income, income decreases by an amount such that saving is unchanged. Thus, attempts by people to save leads to decline in output and leaves saving unchanged. This is what is called paradox of saving. However, this is only relevant in the short run. The policy lesson from this analysis is that even though saving is good for long-run growth, it generates recession in the short run. We shall dig deeper into this towards the end of the book when we address the issue of economic growth. Summary: GDP is the sum of the spending carried out by the economic agents. In the short run, output is determined by demand, which is in turn determined by income. The consumption fraction shows how it is being determined, and the MPC gives how consumption changes for a change in income. Factors that changes equilibrium income include government spending, autonomous consumption, investment, taxes. An increase in any of the first three mentioned will lead to increase in equilibrium output. Equilibrium output is also established when saving equals investment, that is, when leakages equals injection. The saving-investment relation is called the IS relation. Continuous saving may not lead to continuous output because of the paradox of saving. This is the end of study section 2. Thanks for listening.